Okay, on the next one, last one for our review, we're going to do what we did in class today. We're looking at that problem from our handout. It was called problem F, and it had a function here that was f prime. It had like a semicircle and then a line that came down like this. I'm going to assign some values for the areas under the curve. Let's say that this area under here is pi minus 4. Let's see if I can zoom in on that. 4 minus pi. I couldn't even see it. All right, so the first area is 4 minus pi. The second area is 4 minus pi. The third area is 1. And then this one isn't drawn to scale, but we'll say it's a large area, is 15 below the curve. And again, this is a picture of the derivative of the function f. Here are the questions. Where is f concave down and decreasing? Find the local max and min. And I think also on that one, find the absolute min. Gosh. All right, I forgot to write that on there. So I'll add it. Find the absolute minimum. So, and then part C, if f prime of negative 4 is 3, and g of x equals 2 times the function cubed, the function f cubed plus 5, then find the slope at g of minus 4. All right, so I'd like you to try these on your own with this picture that you can use from your handout, and try these questions instead of the questions that are there. All right, so after a pause, let's go ahead and answer them. The first one is looking for concavity and decreasing. So I'm going to go ahead and sketch this function. So let's see if we can do that. Here's the function. It starts out with a derivative that is positive, but it's becoming less and less positive, and then it zeroes out. So is that becoming easier to decide? It doesn't have to start there, but I'm just starting somewhere, and I'm sorry, the values become less positive, and it has to actually have a zero derivative at x equals negative 2. So I'll put a point of interest there, and I'll put a point of interest where I started. And now the derivative is still positive, but it's going up slow, like maybe 1/3, 1/2, 1, 2, 3, and so forth. So I'm going to continue with my positive slope until it reaches the slopiest place, and that is right here. That's where we have a slope of 2, so I'm pretty high slope there. And then it stays positive, but less of a slope, so we have another wobble, an inflection point, and it's going to have less and less slope until it zeroes out right there. And at that point, the slope becomes negative, so we actually have a mountain point, and it stays negative, getting more and more of a negative slope. All right, so did your function look like that? All right, I bet it did. So I'm going to start and stop, give some endpoints, although I don't know where they are, but I have some information to help me with that. All right, the local max and min. I don't see a local minimum, but I do see there's no valley here, but there is a local max. Remember, local max and mins do not occur at endpoints. And so how do I know that that is a local maximum? Well, the derivative over here is going to be positive to the left and negative to the right. And that is indicative of a local maximum. A minimum would have the opposite type of derivative occurring to the right and left. All right, now the question also asks for, well, what is that point right there? That point took place at, what is that, 1.5? looks like 1.5, and we're not sure where the top is yet. So we'll just say for now, we'll figure that out when we do the absolute min. X equals 1.5 and Y equals, for this is a local max, and we're gonna improve that answer in a minute. We'll come back and finish it. There is no local min. Let's find the absolute minimum. So we are wondering if it's going to be here or here, which one is the lowest. So the problem stated, I didn't state it, but on your paper it states that f of 0 is 5. So I'm going to put that in. And that's where we have to have a starting point. So we talked today about area under the curve is displacement, or position. So if we're at 5, the only thing is when you go this way, and that's what we're going, because this is where it equals 5, we have to move to the left. That creates an integral, so to speak, the area of the curve. If we're going from 0 to -2, that will change this positive value to a negative value. So normally we would integrate from the lower number to the higher, but here we're going from the higher number to the lower number, which creates a negative position change. So that means we were at 5, and then we subtract 4 minus pi, and then we're not all the way here yet. We have to get over to x equals -4. So we're wondering where this point is. So you can see the area under the curve, and to get from here to here is another negative value because we're integrating from the higher number to the lower number, and we're going to subtract another 4 minus pi. So if you put that in your calculator, 5 minus 4 minus pi and another minus 4 minus pi, it comes out to 3.28. So we know this value is -4, 3.28. So that might be the minimum. And now I have to check on this side to see what's going on here at this spot. So at this spot I start back here where I know my value is 5, and to get to here I notice the area under the curve is first a +5 and then a -15. So easy calculation, 5 plus 1 minus 15. And that brings me to a -9. So this value here is 4 minus 9. It is definitely the minimum value. So let's go back and finish over here where we have the x value was 1.5. Remember right here we were wondering how high that went. And 1.5 corresponds, if we started at 5, 1.5, the position changed from 5 to this position is the area under the curve is 1. So we go from 5 to 6. So I'll go back and put that in. That's the max. All right, the last question requires us to take this function and take the derivative of it because we're looking for the slope of g. So the derivative on the left will cause us to take the derivative on the right. The 3 runs down in front and joins the 2. 6 f of x to the 2 times the derivative, chain rule, f of x, and the +5, the derivative drops out, is 0. And we have some values to put in. We're interested when the derivative is at -4. So we're going to put in a -4 everywhere there's an x and finish up. So we get 6. F of -4 is given in the problem. No, f of -4. I think it should have been given in the problem. This was supposed to be f of -4 is 3. So I'll go back down here. F of -4 is 3 squared. And then f prime of -4 is, where's that going to come from? It's going to come from our graph. So we go back up to our f prime function. And -4 If we go here, what is the value there? If you check it, I believe it's 2. All right, so I'll go and put a 2 there. So we get 6 times 9, 54 times 2. And 54 times 2 is 108. All right. All right, that's pretty much it for our review, and I hope that it will carry through. See you tomorrow.